Hi, my name is Will Starkey, and this is my presentation for Lab 2 for Physics 2212. To start off, we'll talk about a few of the main goals of this experiment. First was to compare the point charge model to the model of a line charge of two pieces of tape. And next, we're going to find the electric force of the charge when looked at like a line charge compared to that point charge model. Some fundamental principles of physics we're going to be using is we're going to be using Newton's second law and Coulomb's law to calculate the charges of the tape. We're also going to use superposition to be able to divide the charge of the tape in or that supervision covers. So introduction to the results, we can see what our lab looked like on the right, and we saw that Fg was equal to the force of the electricity, which is 1.69 e to the negative third. And this was gathered through using superposition. Some physics principles that we also used were the force of gravity, which is equal to m times g, the Coulomb's law, which is the F equals k1, k q1 q2 over t squared, while also calculating the electric field. Now, the calculations of this first part of the lab. This was from when we used the piece of tapes and we counted them as a line charge in lab 1. And we can see we used initial conditions as our system was tape B, surroundings being tape A, with the tape length being 17.2 centimeters and our weight being 0.172 grams, with the distance between the tapes being 20 millimeters. Now, if we looked at the math, we saw that the force of gravity was equal to mg, and that was equal to k q squared over r squared. And that's how we knew that our final charge was 8.66 e to the negative ninth coulombs. And this was in the first one. We are just considering the tapes as a point charge. So if we make a computational model of the tapes as line charges, but still use that Q from the point charges, we can see we have our mass of one of the tapes. We have our Q that we just found, plugging into all this, which calculates the arrows, and this shows the arrows that we use if the tape was a line charge. And we see that this charge is so much smaller than the force of gravity. The magnitude of electrical force is less. Now, this is because we used Q from our first when we only considering it as a point charge. If we consider it as a line charge, we can calculate it using some of the formulas we derived in lecture. Right here, the force of electric, right here. And then we can find Q using this formula. And we know that Q is 4.513 to the negative ninth. Now, if we use this number instead, we can see how the magnitude of electric force is much closer to the gravitational force. And this is what we are expecting, because this is the difference between the charge on the tapes as a line charge versus a point charge. We can see the line charge is far more accurate. Some similarities between these two different simulations were they were both calculated the charge given by the tapes, and both showed how the charges and force of gravity affected the tapes. But the differences was that lab 1 was calculated with point charges, and 2 with a line of charges. So, and this led to more exact numbers in the computational model and higher accuracy as the line charge is more representative of how the charges in real life would react. We can also look at some sources of error, being human error, of course. Humans can never make a precise and perfect measurement, so there's always going to be error in that. The calculation sig figs, because of how Python and GlowScript work, there's always going to be some significant figure errors, very slightly. And also error in the arrows. We saw that the first one had an error in the arrows. They should have been equal, but it's going to be slightly different just because of error. What can we conclude from all this data? Well, what if we did it as a line charge instead of a point charge? Well, we concluded that the line charge would be more representative of real numbers, as it closely models real life. In real life, the charge isn't due to a point, but a multitude of charges in the line. So if it was evaluated as a point charge, then the answer would be like less accurate to life. Now, why is this? Well, as previously explained, it's because real life accuracy and how the charges in life are perceived. We know that if you look in real life, it's not just going to be one point in the entire tape, but it's going to be all the little points from all the different atoms, all the different things affecting its electric force. It's going to be all that together. And that's how we know the line charge is going to be more effective. And with that, this concludes my presentation. Thank you for listening.